Hello everyone, my name is Lionel Affognon. I'm a PhD student at the Institut of Mathematics and Physical Science in Benin. I'm doing this conference to present my article entitled Secure Land System Based on the Ethereum Blockchain Benin Case Study. The work was made by Nelson Saho, Eugène, EZIN, and I. After the introduction, I will present the usefulness of blockchain in land management, followed by materials and methods. The last part will be about result and discussion, and then I will conclude. Several African countries found themselves with diverse land system tenure after colonization. This is not without drawbacks. In rural areas where a large amount of land is still held in common, ignorance of the land tenure system to the detriment of verbal agreements leads to conflict. Land disputes do not only involve the illiterate population, but also land specialists such as surveyors and other specialists in the field of land tenure. As part of improving land governance, the government of Benin has implemented several projects. The section 1 of the presentation presents the usefulness of the blockchain in land management. Our society is increasingly faced with a constraint relegated to litigation, intermediary, and merely trust third parties, which affect the implementation of optimal land transactions. Intending to secure land tenure and speed up the procedure of transferring land, considerable efforts characterized by solutions already in use are notable. For instance, the provision of a digital cadastre accessible to all by ENTF and the implementation of the e-notary platform. These solutions are based on computer technology except the blockchain technology. The use of the blockchain will improve land management since it is transparent, immutable, and decentralized. Blockchain technology can provide the same functionality as a land registry system, namely registering a land, knowing a landowner at a real time, ensuring unique ownership, tracking transactions, monitoring the transaction history of the land. Beyond these aforementioned features, blockchain can provide additional functionality. Thanks to its shared database, it offers secure backups. Trust is added by its cryptography and security mechanism. Because of the private key, it is not possible for a non-owner to make transactions within it. All these potentiality make the blockchain a trusted tool for securing land and make it a safe alternative to conventional land registers for the time being. In this section, I will talk about materials and methods. Ethereum Blockchain is an open blockchain for the development and deployment of decentralized application. A decentralized application is an application-friendly user interface based on a smart contract. Thanks to the smart contract writing in Solidity programming language, a computer can facilitate the exchange of money, contents, property, shares, or any object of value. Simply deploy the smart contract on the Ethereum virtual machine and it will run automatically when specific conditions are met. EVM has allowed the Ethereum blockchain to go beyond the primary purpose of blockchain, which is to offer only a crypto money service. EVM makes the process of creating applications based on the simpler blockchain. We do not need to create a blockchain entirely for each new application. Ethereum allows the development of thousands of different applications on a single platform. We write the smart contracts thanks to the Open Spatial library. It provides tools to write, deploy, and operate decentralized applications. It includes the most widely used implementation of the ERC standard. It allows the creation of the single identity tokens. In other words, these are tokens that cannot be replaced by other tokens during an exchange because they do not have the same value and characteristic. According to the requirements of this standard and depending on the type of data we have to handle in our solution, we use a uniform resource identifier. In our solution, the URI represents a JSON file stored in our server that characterizes a LAN. It includes the GPS coordinates of the various maker, the LAN title number, a descriptive text, and a link to an image. All this was done in the truthful development environment. Spatial database management systems are engines for managing database of data that incorporate spatial components. We choose PostgreSQL because it is free and open source and almost as powerful as Oracle Locator, which is a proprietary product and not free. For online mapping, we had the choice between open layers and leaflets. This table shows the result of a comparative study conducted between these two libraries. We used the GeoJSON format to provide land coordinates to leaflet library for the displaying. Our work was carried out to the phase of analysis, designing, and implementation. In this step, we identify the different roles of our application and their different implications. A client launches a query through its web application. This query depends on the type of user. The notary user has the possibility, based on the convincing document provided by the landowners, to create the assets. The owner user disposes of this asset on its account. The use case diagram presents the functional interaction between the actor and the study system. It shows the system from the actor's view. The class diagram shows the different classes to the system and the interactions between them. It describes the internal and the static structure of the system. This table provides a summary of different tools and language used in the development of our solution. In addition, for the function of the OpenZeppelin library, we have writing our own function that are adapted to the assets we handle. This figure presents some land in red registered in our system. Indeed, when a land is registered by a notary, its coordinates are retrieved and transformed into GeoJSON format. The landowner can view all the land belonging to him as illustrated in the figure and can perform different operations. To transfer a land, after selecting the transfer option, the current owner must fill the public address to the new owner. This work consists in the implementation of an application to secure land in Benin thanks to the blockchain technology. This application is associated with webmapping technologies. Our researches allowed us to realize that there are existing solutions and was carried out in the same field in Benin. It allowed us to cut the intermediary during the operation of transfer of acquisition of land. In spite of the problem solved, our application also has shortcomings. Thus, we have noticed that our solution will be difficult to access for rural population, most of whom are illiterate. Thanks for your attention.